I would say, yeah, one thing that I forgot to mention that is actually really important. This is before you would want to do before you start a PhD. You just have to you need to try to do research before you try. Even if that research doesn't go anywhere, just try to do research. Try to work with a professor. Try to see if this is something you'll enjoy. And the best way to do it is to literally just try it. Spend a couple months, a summer or something. See if it works out. See if you're interested in it. See if it's fun for you. Because that is like the biggest, most important thing. If it's not fun for you, it would be like hell. Like
Yeah.
you wouldn't be able to go through with it.
Okay, everyone. Today I am here with Alek Dmitriev. Say hey, Alek.
Hi.
Tell us about yourself. Take 30 seconds.
Right.
Give us a little bit about your background. Obviously, as it relates to your PhD work in computer science.
Yeah. All right. So 100 years ago, this little nation.
Going way back.
Right, well, first, thanks for having me. It's great. All right. So
yeah, it's a pleasure to have you here.
Yeah, thank you. It's really fun. So yeah, I am from this little country called Macedonia. It's kind of in the southeast corner of Europe, and I did an undergrad and master's in computer science. But it was really interesting because I kind of found out about this field called machine learning. I say called machine learning, but I think everyone has heard of it by now. I feel like it's everywhere in the news right now, all about like those algorithms controlling us, right? Everyone's scared of that. So it's
Deep fakes.
Yeah. Oh yeah, deep fakes. They were big. Yeah.
We'll talk about that.
Yeah. So when I first started looking at it, it was like 2014, I think, when I found out about it. It was totally random. There was like a Coursera course. It was like the first course on Coursera was actually machine learning because the founder is like a really famous professor in machine learning.
Mm-hmm.
He doesn't even do that anymore. He works at like Baidu now, but he just wanted to like spread the knowledge of like what this is and why it's so cool. And he did an online course. I took it and I was like completely enthralled. Thought it was amazing, and I was like, I gotta learn more. So then I was like, okay, I gotta get my master's. It was at the same place I did it in Slovenia. And then I was like, I want to get a PhD. I want to see what the cool people are doing. Like, where are they? And it turns out like most of the cool people are in the U.S. Like it just so happens. I don't know how. Like it's just one country. It's not like the biggest country, but all the best universities are here, and all the best professors are also here. There's like a couple maybe in Canada, and it's like maybe a couple in Europe, but most of the good schools are here. So I thought I'm just gonna apply to a bunch of schools and look at what professors are doing cool research. At the time, I was just doing something with like discrete latent variables or something, and that's how I found out about like all the professors who work in that field, and I looked at what their research is, and I was like, okay, I'm citing these professors a lot. Maybe they're really good at like what they're doing, and even though like my interest shifted later, it was still like the professors that I found were probably a great fit because one of the professors is one here at UT Austin. That's my advisor. And like it was so I applied to like 10 schools. I got accepted at a couple. And
where else did you apply?
Oh yeah, it was a couple of schools. I didn't want to go to like apply to the crazy schools. They're basically like there's like 4 or 5 really amazing schools in machine learning where like you have to have like a top tier paper published before you even apply. Otherwise, you're not even going to get admitted. So those would be like Stanford, MIT, Berkeley, and Carnegie Mellon. Those are like
the usuals.
Yeah. Yeah. Like the first two are really amazing at everything, right? They're known. CMU, I feel like, is not as well known, but especially in computer science and machine learning, they're amazing. And
you say CMU?
Yeah,
CMU?
Carnegie Mellon.
Oh, Carnegie Mellon.
Yeah, Carnegie Mellon University. Yeah. I just see it abbreviated like that a lot, and yeah, it's so I was like, I'm not even gonna try there. So I tried like the schools that are kind of right under there, and UT Austin was like, it's definitely like I would say top 10 if not top 5. Like has some amazing professors. And this was like basically my top choice for where I think I applied to. I don't even remember now because it's been like 4 years actually, since it takes a while. But it was I think it was like the NYU had like a data science PhD that I applied to. There was St. Louis, Washington University in St. Louis that had a good computer science program. Some professors there. I basically just looked at professors that I would be interested in working with because sometimes, even though you might think this school is good, if they don't have professors that are interested in machine learning or specifically what you are interested in.
I want to come back to this. But
Yeah.
first, I want to ask you some questions about all that you just said because there's a lot there.
Yeah.
But I definitely do want to get to what you're talking about in terms of like, how do you find the school that's right for you? Like is it just the credentials of the school, or no? It obviously depends on the professor that's doing the research and who what you want to be doing. So, but first, going back to when you found the Coursera machine learning course, was that just serendipity? Like, how did you stumble on it? Did you see like, oh, Coursera is this cool new website and go check out what it was? How did you hear about it?
It's hard to remember. I'm trying to remember right now. It's been so long. I think. Well, okay. So it was at the end of like my second year of undergrad. I remember before I knew about this, I kind of didn't know what you could do with computer science. I assumed that everything you could do was, or like the two things you could do was either web development or app development, and that's literally what I thought it was. I didn't even know there was anything else. Okay. Yeah. So, but then I like the thought of it was like kind of boring to me because I don't know. I just never found it so as fun as I guess other people did. So I thought like I was like getting depressed, like, oh, this is like not fun. Like, am I getting the right major? Like, I don't know, have I done a mistake? And I always loved like just learning about like the universe. Like I loved astrophysics, like the idea of it, and I had fun with like math and physics. So I was like, maybe I should go to astrophysics. And then I talked to this professor of like the Macedonian Academy of like arts and sciences that my mom just knew personally. She was like, you should just talk to him and maybe he can advise you. And so he just mentioned, he was like, have you heard about machine learning? I was like, no, I haven't heard. And it turns out he also like, he basically did his PhD in physics like years ago, but then slowly transitioned to this field because it was interesting and cool and like growing. Yeah. And he like told me what that is, and I was like, okay, I guess I'll look into it. And basically, I think that's how I found out. I probably just Googled online and found out about Coursera, and then took that course. I think it was, kind of like that.
Nice. And so I've thought that you don't need a master's to get a PhD. Is that right? Or it's not? You did a master's. Why did you decide to get that master's before going a PhD, or did you not even know you wanted a PhD until you did the master's?
So I think it's probably due to the different systems between Europe and the U.S. Okay. In the U.S., it's more traditional that you do a 4-year undergrad and then you just do a straight PhD, because usually it's like the first year of the PhD here is kind of like getting a master's because you have a lot of classes, you're not doing much research, and versus Europe where a lot of the places now have this like Bologna system that they call, where it's like a 3-year
Bologna system.
Yeah, I think it's probably due to that University of Bologna, like one of the oldest universities in Italy. So I think it's named after that, but it's like this Europe-wide system. A lot of universities subscribe to it, where like the undergrad is only 3 years. So when I finished my undergrad with 3 years, I felt like I don't know anything yet. So then I took like a 2-year master's, and then I felt like more rounded that I could apply. And I feel like I really didn't know enough when I just finished my undergrad. Like I felt like if I should get a job right now, I really don't know anything. I just felt very like unprepared for the real world. I don't know how to explain it.
No, I think unprepared is the perfect way to put it.
Yeah.
So on your specific interests and research, tell us a little bit about that. It's not just machine learning. I'm sure that you have a much more specific focus. And what year are you, by the way? I didn't know.
So I'm starting my 4th year.
Fourth year, okay. Fourth and final.
Actually, PhDs usually take like 5 years.
Okay.
So it depends on the department. I've seen people graduate in 4, depending on what you want to do after your PhD. If you want to just work in industry, it's easier because you can find a job more easily. And then you can just go off in 4. Most people, I think, take 5, and some people take 6 if they really want to get like a good resume because they want to apply at really good schools. So they basically there's nothing bad in like staying a little longer because you can kind of publish a couple more papers maybe, or like you're just waiting for this one paper to get published so you can use it in your application. And people, take a bit longer. But I think it's like a 5 years. This is for my field. Obviously, it depends on fields.
Sure.
There's I think I've heard that like life sciences take like 6-7 years.
Oh,
it's hard. And then they do like several postdocs, which take like a couple of years, which is like not common. Like in my field, maybe you do like one postdoc that takes like 1 year. So that's basically you just go off at a university. You just work there as a low-paid researcher. You're not a student anymore. That's it, and you're just doing some research. And that's like a thing that people do to kind of improve their resume a little bit more. And then they go on it's like if they want a job as a professor, you really have to apply at like almost 100 schools. Like most people that I know that finished in my department, they're graduating on jobs. They were applying to like 80 to 100 schools all over the country, or maybe even like outside.
For postdoc positions?
No, so you can do a postdoc. It just really depends on like what you want. So for my field in machine learning, some people do postdocs, but I'm actually in the business department at UT. So I have a lot of people who are not that close to machine learning, closer to like supply chain operations management. So for their field, like postdocs are non-existent. So they just apply directly to academia to become a professor. And I guess those are ones that take like 6 years. So you can take like you can take a shorter time and then get a postdoc. It just depends on what you want to do.
I see. Okay.
Yeah.
Yeah, it's always mystified me. Like, what do you do after a PhD? And I want to ask you about that, about what you want to do. Like research, industry. We'll get to that in a little bit. But about your specific research area.
Yeah, that was the question. I dodged it skillfully.
Like a true. You sure shouldn't be in politics. You run for mayor, governor.
Yeah. So I've been working basically on how to train models where you have discrete parameters. And so if anyone remembers from calculus, you can take a derivative of a function, but that function has to be continuous. If it's not continuous, it's kind of problematic to take a derivative of that function, and that makes you like you just need to work with other ways. Like there's other mathematical ways where you can kind of train a model, because what's going on is most of the models that people train, they have like this. It's called like a loss function that they try to minimize. That's basically how people, when they say they're training a model, they just have like a loss function that they train on.
Are you saying loss or lost?
Loss, as in LOSS. Like it's just a loss function. Yeah.
Loss function.
I don't know where the term comes from. It's just something that you want to minimize. And so it would be something like, let's say the error rate of your model. Let's say you count up the number of mistakes. Mm-hmm. So, for example, I think I should give an example. It'll be clear. So right now, for example, what I'm working on is one application of my, like it sounds weird to say this. It's not really my. Okay. It's more like, it's sort of like, because you always work with an advisor, so it's never really like your method. It's like me and my advisor's method, and like other people that I collaborate with. So yeah. Our approach is, and that's how people write in papers. Even if you're like the sole author, you would always put our. Like you would just say like our approach, our work is doing this. You never say like I'm doing this. It just sounds very strange to read that.
Because everybody knows it's not just you.
Yeah. Yeah. So like our approach right now is we're looking at when you're training these neural networks, you can use different loss functions, but one that you can't really use is counting up the number of wrong examples, because that is not a continuous loss function, because you're either right or wrong. So it's kind of like a 0 or 1. You can't really be like half wrong. Now people have gone around that by basically trying to look at like what is the probability that the model is outputting between 0 and 1. So it's like 0 being not at all, and 1 being like I'm sure it's this. So you can kind of do that, but then like you're not explicitly attacking what you're supposed to be. Like what you're supposed to be minimizing is just like the number of wrong examples. Mm-hmm. And so our approach is kind of, what if we actually try to do that directly? But to do that directly, it's a discrete function, like it's 0 or 1. So you need like a special kind of math to do that, and that's where our like approach kicks in.
And how did you land there? Honestly, a lot of that right over my head.
Yeah, no, I mean, as I was saying it, I realized like there's so much jargon there.
No, it's okay. There might be a lot of people that are thinking about this area, or that are slightly familiar, and so that I'm sure that it's a value to some people. How did you arrive at that topic, at that field? Like, I'm sure that there's a lot of things that are popping up in machine learning, and there's a lot of competing interests that you might have had, but. Yeah, tell us a little bit about how you landed there.
That's a good question. Yeah, I think I was just working on different things. Like, I mean, I think the life of a PhD student is like you try a lot of different things, and most of the things are not going to work out. And it's really hard on like even the psyche to just keep trying and like failing at things, because you just try something and it doesn't work, and like I guess I wasted a week of working on this because I just can't seem to like get good results on this. So because you have to get like good results, otherwise it's not that like it's not worth it to anyone, like the knowledge itself, but it has to be useful. Yeah, in a way it has to be. Yeah, so you have to like show some good results, and if you can't, like just forget about it. It's gonna be hard to even publish it. So don't even bother like wasting time for something that might not be published. You gotta make sure it's really good. Yeah. So it's a lot of it is just working and trying out different things. So I was trying a lot of different things. I can't even remember like how many different things I've tried. I've read a lot of papers.
Could you throw like two or three examples?
Yeah. So, for example, when I started my PhD, the first few things, we had a reading group. Like my advisor had a whole reading group. We were reading different papers. So we were reading something on a paper, something called like a variational autoencoder. It's just it was a thing that was really good at generating images. So it was a kind of a revolution in machine learning recently, where there was two different ways completely different approaches that people found to be able to generate something realistic like an image. So it would be, before that, it was kind of actually hard to make the computer be able to generate some images or something that you want, like some real life example. So let's say
on its own.
Yeah, yeah. So like, what I mean is, if you give it a data set, like a data set of images, a data set of sounds, or anything really, and you say, generate me the data, some data that is not exactly this, but like looks like this. So it would be, for example, if you have a data set of cats and dogs, you just want to make sure that your model can generate cats and dogs, but also you want to make sure that it's not just generating the exact images that you fed it, right? That's actually a really important thing. You don't want it to like remember what the images are and copy them and just give you the same thing. It has to be unique. Exactly. It has to be like a really unique thing. And what is done, the two approaches are very different, but they both work with a neural network, like a giant neural network that is fed complete noise, and that noise is completely one of them completely deterministically transforms that noise into an image. So it's fed like, imagine like a sequence of, I don't know, like 50 numbers. I mean, it's not a sequence, it's not ordered. It's just like 50 different random numbers. Yeah. And those 50 different random numbers correspond to, this image of a cat. And then you just give it a different number, a different set of numbers, and it'll just generate a completely different image of a cat. Mm-hmm. And all the images that they manage to generate are actually like good-looking cats. Yeah, they're very sexy cats.
Good-looking cats. Yeah. They're good-looking cats.
Yeah, they look bad. Yeah. But then there's another model that also tries the same thing. But for example, that one would generate like more blurrier cats. Like there's a whole thing. But that was like one of the first things I tried was something like that. I was trying a different way to train this. Like there's different, like if you change that loss function to something else, you can achieve different results. And there's been a lot of papers where they just change that into something else. Like what I'm talking about, they're called generative adversarial networks, GANs. They're very popular right now.
Adversarial networks.
Yeah, because it's actually very interesting. Like the concept itself is so cool. It's one network is the one that tries to generate the images that like goes from noise into an image of a cat, but it has no idea how to actually do that. But how it learns is, you could have like a human try to say like, no, this is bad, this is bad, this is good. Right. The problem is, how do you even, like, there's not even a chance that the network is going to generate something actually good by chance, because the space of like possible images.
The chance it generates a dog and you're able to tell it, yes, that's a dog, are astronomically small.
Yeah, it's all going to be white noise. Yeah. Like most of the images that could exist and possibly are basically white noise. So what there is, and the idea is they have another network that tries to teach it in a way that that other network just tries to differentiate between an actual image of a cat or a dog, or like the noise that is being generated by the network. So that's how it is being.
So one network is training another network.
Oh yeah. So because this network has to learn how to differentiate this complete garbage noise from the actual images. It has to learn something about like what is in an image, right? So it has to learn like, oh, this is noise and this is cats. Right, but the thing is, that information is also given to the other network, the generator. So it knows, like, okay, so what happens at like the actual, I guess, the details is, let's say that this first network, like the discriminator is what it's called, the one that tries to see like what's noise and what's a cat or a dog. That one, for example, would maybe like it starts learning that just completely random pixels don't make sense, and they see like, okay, it has to have like two eyes and a mouth. It tries to like find something in an image. Like this image has to have two eyes and a mouth. So then like that signal is being fed to this other network through the derivatives of this function, and it learns like, oh, okay, so I need to generate something with like two eyes and a mouth, and start generating that. But then like this other network is gonna learn like, okay, well, that's not all there is to this image, right? It's because you keep telling it like, okay, this is good and this is bad, but there's a lot of other things that are different between the two images. It's not just that, eyes and a mouth. There's a whole cat here, right? There's like a background that has grass, or, there's like a wall or some sky. So you have to generate that too. Otherwise, that's going to be like the thing that this network is going to find out about, right? It'll be like, okay, well, you did generate, eyes and a mouth, but you're not fooling me because, this image also has like grass and some sky. So you got to generate that. And then it learns doing that. And then slowly until there's nothing left to discriminate, and then in the end you're really left with this network being able to generate images exactly alike.
That's wild. And so that was the first thing you did?
Yeah, that was the first thing I was trying. I was trying to change the way that this was trained. I was trying to use a different method to train the two networks. That's basically what
And
I was
eventually
trying.
that didn't work out because
Yeah,
obviously you jumped to quite a few other things.
yeah.
What was the second thing and the third thing?
Let me think. So like I'm trying to think of like the bigger things. There's also a lot of smaller things that you, for example, like you read a few papers, you try it out for like a week and it doesn't work out. So that was the first thing. There was, let me think of another thing. So there was so I knew my advisor was working on some discrete estimators, and I was trying to see if I can come up with one, and I did come up with one. It was getting some like pretty good results, but they were just like not good enough to be able to work with them. And then they were like, it turns out like someone slightly improved on what I was working on.
I'm gonna turn this just a little
And yeah, and they were like, I saw some papers being published that were basically like what I was working on, but like slightly better, like just like a few tweaks on what I was working on. And so it like two different, even like another student in my department was working on something else, and then when he improved like that estimator that I knew, so my advisor basically had this estimator with another student, and it was pretty good. So I was like, maybe I can come up with my own different one. And mine, I was like, okay, this is not good enough. But then he tried like an improvement to his estimator. And then when I looked at that improvement, I was like, oh, this is exactly if I improve my estimator, but it's but from a different approach. So we kind of like landed the same thing, except like him and this like completely other team at like Google Brain already had like run some experiments, and they wrote a paper and they like published it already. So I was like, by the time I realized like,
Shit.
oh, if only like I improved my estimator this way, it would have like converged at the exact solution that both of these groups did. So but if you think about it, they also had the exact same thing, also from like a slightly different approach, but they also came up with like the exact same solution. So that's what I was talking about when I say that it's moving so fast that like if you don't think of it, someone else will.
Someone else will.
And yeah. And to be fair, I didn't think about it until I saw, like, once I saw the thing, I was like, damn it, this looks so close. And I was like, yes, it is. And I was like, oh, if only I did this, I would have gotten it. So yeah, that was like another thing that I was trying. It was that was like a different gradient estimator.
And so when did you land on your current topic? How long have you been working on that? I mean,
this has been.
Has this been the past few years that you've been working on?
Oh
this?
no, it's definitely
okay.
been like this year. I think it was
Okay.
it was in. I would say like maybe March. I think I don't remember exactly. It was a couple of other things. So I'm working on this right now. I was working on something else. I was working on like another thing. This was it was like another different way of generating images that I actually have not been working for like 2 months now, because I'm trying to get this first thing pushed, the one I'm focusing on right now. But there was another thing where I was trying to improve that thing we talked about, the GANs, with like how to generate the data. And there when you generate data, you just give it like a bunch of images from like the generator and a bunch of real images, and that's it. Well, what we were thinking of, what if we tried to kind of pair all these images together and see like, okay, so you pair like two collections of images together, and then you say like, okay, well, I want like this image to be closer to the real image, and then for that other image to be closer to this other image. So you hope that like you can pair them quite well, and then you say like, okay, well, I also want to make sure that all these pairs, I want like the fake image to get closer to its corresponding pair. So that was another thing I was working on. It looked pretty promising, but I just like shelved it for a couple of months because I was like, I just need to focus on this one.
So this is not at all what I thought a PhD was. Like, honestly, going into this, I thought a PhD was like, you have to go in knowing exactly what you're going to be working on like the whole time, but that's not the case at all.
Oh, no.
So on the practical side, what is your day-to-day like? Like, how much time do you spend? Are there any classes that you're taking, or is it all?
I was taking a lot of classes at the beginning of my PhD. So like my first year, I barely did any research because I was taking 3 classes each semester, and they were pretty intensive. And I was at the same time I was like reading a lot of papers, trying to like catch up on the field.
Can we talk? Let's talk about those years kind of in succession, like however much detail you want to go into. But
yeah.
Okay, so what's the first year like?
So the first year is basically you try to learn as much as possible. Like if you can contribute to something, sure, that's great. But no one is asking you
or expecting you to.
Exactly, not even like close. You're just, because usually my program, and I think a lot of programs, maybe not all of them, they have an exam at the end of the first year where they basically test you on just a very general knowledge of the tools that you'll need to do this PhD. And for my field, it's basically math. Like you just need to know a lot of math to do well in this field. Like, coding, you can, I guess, kind of like you'll learn it, and it's kind of hard to, I guess, test for coding.
That's the tool, but the math is the
core.
But
like the math is what you're taking classes in, and it's
the language you got to speak.
Yeah. So that's you're given like a hard test on. For me, it was basically just statistics, because that's what we're doing right now with machine learning. A lot of it's just statistics. That's the math we need. So it was just a test that I took with the other PhD students in statistics in the Department of Statistics at UT. And maybe like a couple other students that need to do it, and we all took this like 3-hour test, and they were like, okay,
damn,
yeah, I think you get like one more chance if you fail, so you can like try it again in the second year, but then if you can't, like, you're really out. You just like kick you out. Well, you have to like so I'm saying like maybe you don't have to pass on like the immediate first try, but like if you don't pass it on the next try by the end of your second year, then you're really just kicked out.
Yeah, they gotta be like, what are you doing here, man? Like,
yeah,
it's a gut check moment.
Yeah. I think most people pass it though. I guess it depends on the department whether they will admit more students than they can work with or not. Like some departments do that. I had a roommate who was in the biology department at UT, and he said that maybe like too many people accepted or something, and they knew they had to like kick like a third of them because just everyone seemed to accept their offer. It just happened, it was just chance, randomness, and they expected 12 but had like 18 or something, and they had way more students than they could. So I'm guessing they're using that to like filter out.
Well, I mean, the fact that everybody is passing the test is probably a good thing, because if they were admitting people that didn't pass it, that just feels like the application or vetting process for the PhD program is off, So it makes sense.
That's true. Yeah, it's true. But yeah, that's the first year is just a lot of learning, a lot of learning, like going to classes, learning, and then just trying to like read papers in your spare time so you can catch up and see like what's interesting. Yeah, and then in your second year, you do take like some classes. You don't really have. I'm trying to remember. There's some. I think every department has their specific prerequisites that you have to take, like this, and that class, or at least one class in like this math or whatever. So it just depends on the department, like what classes you need to take. In the second year, I think it's good to take quite a few classes, because it's you still are learning a lot, and you might not have like something specific you're working on.
Mm-hmm.
You should be working on something, but like just like you don't let the time go to waste. You're like learning as much as you can, and there's more than 6 good classes at UT. Like there's a couple like really good, not a couple. I mean, like there's dozens probably really good classes. So you'll just choose like what you're most interested in.
Yeah.
And you take those classes. Then you're just slowly
still in exploratory mode.
Yeah, but you're starting to like you find like this person to work with. You probably try to work with different professors, or like if you're lucky and you just find like one professor, you're like, okay, this professor is great. I'm just gonna work with them.
Mm-hmm.
They're doing great work.
All right, so that was year 2. Now a little bit about year 3. What's that like compared to the other ones?
Yeah, well, it all blurs together. Honestly, now that you ask me, I'm thinking it's because year 3 was, I guess, half of it was normal, and then Corona happened. So
yeah.
So that was like most of my.
Are you on? I mean, like, do you still go to campus? Or are you online? Or?
Oh no, not at all. No.
Okay.
I mean, I go like from time to time just for fun, or like to get my bike fixed, because there's like a bike shop right on campus. Otherwise, yeah.
Well, I guess not considering Corona, because it's just different. But yeah.
Well, I mean, it definitely impacts. Like, I was having a hard time at the beginning with working from home, but I think for my field, it's not hard to work from home, because all I'm doing is either I'm like deriving something, I'm just sitting down with a piece of paper and I'm working out the math, or I'm just coding it up and seeing if it works, running some experiments. And thankfully, from my home, I can always just connect to like the supercomputers that UT has. So I can do that from my home.
Badass.
Yeah, that's fine. I can even do it from a coffee shop, although I wouldn't feel safe doing that, because there's always like the chance that someone is like listening in on the Wi-Fi packets, because you're like on a public Wi-Fi, it could be easily monitored. So I try not to do that if I'm like in a coffee shop, but at home, that's fine.
When you say supercomputers, does UT have its own like cloud computing platform, or what does that mean?
Yeah. Well, it's not a cloud. Well, I think cloud means they're like somewhere
distributed,
like somewhere, I don't know, some like data warehouse, which is true, but I wouldn't say it's cloud, because like it is UT. It's not like Amazon's cloud or something. Like it's their own,
You're good.
It's their own warehouse. Warehouse, I guess. I don't even know where they are now that I think about it. I think it's like somewhere north of the campus, like somewhere maybe like the research center. That's like
the JJ Pickle research
maybe
center.
that one. I'm not even sure like where they are, but I know that it has a bunch, and they actually unveiled like a newer one like a year ago. It's like the fastest like public university supercomputer apparently. It's but they like even share it. It's so big that they just share it with people. It has like thousands and thousands of like CPU cores and like hundreds of like giant ass graphic cards. that we need for learning. Basically, what like all of this deep learning is going on like NVIDIA graphics cards.
Right.
That's what we use. Like and specifically NVIDIA because they were really good at like working on this toolkit that really speeds up the computation for training these networks. And NVIDIA has done this, and they have completely dominated the computational market for us like researchers, and like people just try to get like NVIDIA cards. I think like it's that and maybe like Bitcoin mining that probably
it's exactly what I think of. I think of warehouses of NVIDIA cards. And
yeah, I think both those things result in like not being able to buy graphics. I've heard there's like a huge shortage, and actual legit gamers can't find them, and they're probably very frustrated because we're using it for like boring things like mining Bitcoin and research.
That's fucking hilarious. And so year 3.
Yeah.
I guess you're not taking as many classes in year 3.
Yeah.
You're spending your time.
Yeah, it was just like one class I think in the fall semester I took, and that's it. Just working on research, just working on different things. I guess like going to some talks. That was more in person when we're going to campus. There's always like a lot of very interesting talks that happen on campus. There's people coming like to different departments. Like every department just hosts their own people. They have like I would say there's like a weekly talk that every department runs, and they have like really interesting people most of the time, and they have like I think even a separate track for like their own students showcasing their research. So they have those talks. So there's always like there's a complete like there's just a cornucopia of talks that you can go to. So you try to just go to the ones you're really interested in.
Yeah.
At first I think I was trying to go to like a lot of talks, but then I would end up like on half of them I would end up just like sitting on my laptop and just working on reading something. And I'd be like, what am I doing? Like no one's making me go to these talks. I don't have to if I don't want to. So now I just go on ones that are like I'm interested in. I'll just go there and see what it's like.
Is it stressful? Like I don't know, PhD.
Oh yeah, very, very.
Okay.
Oh yeah. Like, oh my god.
You don't seem like you're very cheerful. You're very explosive. Yeah. You don't seem like you have like 1,000 pounds on your mind.
Oh no. I mean, I think it is. I would say it is. Yeah. I guess maybe I hide it really well. But yeah, it's stressful because you're always thinking like, man, if does this thing gonna work? Like you always have it in your mind. You're just like, all right, let me like check on the experiments and see like how's that going, or like if something doesn't work out, you're like. You just feel bad for like a couple of days. You're like, I guess I like have to think about something else. Or like, why does this work? Like, do you have to like scrap it or can you salvage it? It's I would say it's very stressful. It has like the ups are great, kind of like when you get something working, you're like, wow, this is amazing. It's going great. But the downs are like, oh crap, like this doesn't work.
It's very much like a sine wave, and the amplitudes.
Yeah,
are very
exactly.
big.
It's like a sine wave. Yeah, and I think I've seen some stats on PhD students. Like a third. I think it's like a third that drop out of the PhD because it doesn't work out for them in general. And I think it's also the same, not the same third. I mean, it's also a third, like the same number is the fraction of PhD students who have like depression or something. Like I think diagnosed depression. And it's like 1/3 is like a huge percentage. Wow. Yeah, like it's just really hard, I think.
And how do you, I mean, we're getting off track here. I want to come back to the year 4. But first, how do you deal with that? Like, so you say you're stressed. What's different? Why have you not dropped out? You're obviously here. You seem like you're cooking along.
Yeah, I guess it's just I don't know. Maybe I'm more of a like maybe I just have more grit. Like maybe I was just lucky that I'm more gritty and I just stick it out. But I think I guess if you don't find maybe you don't find a good fit. Like maybe your advisor is not. Maybe he's like too hands off, or maybe he's like trying to make you do things that you're not interested in. Maybe he's telling you like do this and do that, and you feel like like a monkey doing its master's bidding, or like the opposite, where like the advisor doesn't care about you and doesn't even like monitor what you're doing, and you feel like you're falling behind.
So that advisor relationship is very important.
Yes, very, very. Everyone says that, and I read that like online when I was reading on like what is it like to do a PhD, and they always say like very important to have a good advisor, and yes, that is like really crucial. Like,
are they hard to find?
Good advisor.
Would you say most? It's like, is it harder to be a good advisor, or is it harder to be, or is it easier to be a bad advisor? Or I don't know if I worded that right. But you know what I'm saying? Are there more bad ones than good ones, or are there more good ones and bad ones?
I think it probably comes naturally from caring for your student. That's what I would guess. Or maybe I'm wrong because I don't have a lot of I have a sample size of one. I have one advisor, and I think he cares about his students. I feel like he cares about like how I'm doing. Like he checks up on me. We have like weekly meetings. I feel like he really wants me to succeed. But maybe a lot of advisors don't. Like I know some friends who say like, oh, their advisor, they haven't seen him in like 2 months. Like he just like forgets about them or something,
Just doesn't give a shit.
Or like an advisor that like makes you like do something that he tells you like, oh, you should do this, and you're like, I don't want to do this, but well, tough luck. Like he tells you like you do it, so you have to do it. Or I guess I don't know. Maybe you don't have to. Maybe you can find a different advisor, but it gets complicated. I guess maybe at the beginning of your PhD, it's easier to switch advisors, but later I think it gets harder. So it's a complicated. But I think it's probably the most important thing is to have a good advisor that pushes you.
The most important thing is to have a good advisor.
Yeah.
I'm going to have giant words like
Yeah.
Okay.
Yeah.
That's good to know. I'm trying to think what else might be pertinent there to ask. Do you have any advice on like finding a good advisor? We may have already covered this in some form or another, but
that's a good
for people that might be watching this that are like, oh God, I got it. I need to do that. Or like, oh shit, I didn't know I needed to do that. What could you tell them right now that might help them find a good one? Or at least improve their odds.
I'm not sure, because I think I just got lucky because I was the professor that I wanted to work with that I mentioned like in my research statement when I was applying. You have to say like, what do you want to do research in? Who do you want to work with? And I mentioned my advisor like Mingyuan Zhou and in the letter, and I ended up working with him. So like he's a really good advisor. He's really nice. So I think I just got lucky. I guess if that didn't work out, I probably would have tried to work with other people, maybe like just message like email or just like go to someone's office and just be like, hello, I'm a student in your department, I see like you're working on this. I mean, you wouldn't just like, I guess, stop by and just be like, I want to work with you. You kind of want to see what they're working on. Hopefully that interests you at least somewhat, and then you say, okay, maybe I can improve this paper. Or I guess you could even just say like, if you have like, advisors have a lot of ideas, and maybe you could just ask them, do you have anything that I could help with? Sometimes if you just don't care what you're working on, you could even do that. Undergrads do that a lot, I think, because undergrads don't even know like what they can work with. They have no idea what the skills are. Trying to get experience. Yeah. So like you would just go to an advisor and tell them, just ask them like, hey, I'm an undergrad, but I'm really interested in doing some research. Do you have anything for me? And usually they do, because advisors, turns out they are constrained on like what they can work on, because they have so many ideas, and a lot of them are going to be good ideas. And a lot of times you'll see the bigger, like the good advisors have a lot of students, and it's because they have a lot of good ideas, and then they talk to their students and they tell them like, okay, this is what I'm thinking of, and then the student obviously like contributes to that, and they work on and develop that idea, and then with another student they develop another idea, and so they just have a lot of students because they have a lot of ideas they want to work on, but they have there's still one person, and unfortunately in like the way their job is structured, they have to spend a lot of time on like administrative things. When you become like a good professor, like they invite you to give talks, which is, I guess I would count that as administrative somewhat, because it's like you're not really doing research and you're not even teaching your students. You're just going somewhere to give a talk that has nothing to do with your job, but people do it because it's fun. You get to meet people, you network, you maybe even find a collaborator. So that's kind of like now you start spending your time going to talks, giving talks, going to conferences. Or just like being on like the admissions committee, or deciding or writing grants. That's like a really big thing.
Writing grants,
turns out. Like I think it's like a single digit percentage of what grants are accepted. So you spend your time writing a grant, and it's gonna get accepted with
single digit percentage of grants are accepted.
Yeah, it's like maybe 5%, maybe lower.
Damn,
it's really low. So you spend like dozens of hours, maybe even more. Like they're like dozens of pages long, maybe even up to like 100 pages long, and you just write that grant, and then you send it to like NSF or something to see if you can get it funded. And most of the time it's gonna be a no. But when they do, like they do come with like probably hundreds of thousands of dollars. So it's a lot of money that is being brought when you do get a grant, and that's really appreciated by the university itself. They like professors who get good grants. Yeah. So that's another thing. Like they spend a lot of time. That's not really directly research. So that's how like I can work on the supercomputer. Is my advisor probably wrote a grant where he explained his need for some number of like compute hours on this supercomputer, and he was given like I don't know like 1,000 hours on this supercomputer that he can like portion off to his students. And then we can like just log in and just spend them like getting our models working.
Because that's essentially money. I mean, in the form of energy.
Yeah, basically. Yeah, exactly. Although I hope that for our supercomputer at UT, there's a higher acceptance percentage than like some low digit, like single digit. Yeah.
Yeah. That's helpful. And so back to year 4. So now, we were at year 3. So year 4, what's it like now? Looking back at the other 3, and you say they all kind of blur together, but compare, contrast.
Yeah, I guess it's not much different. I think it's just like you slowly transition uh, from learning from like going to classes and from reading a lot of papers very widely in your field to kind of focusing on specific things. And now I'm not taking any classes. I'm just doing research. I mean, I just started my fourth year, so I guess I can't speak about like what's all gonna be.
Mm.
But like at least right now, I'm only reading the papers where there's something that there's like some idea that you have that you want to see if anyone has done it. So you do kind of like a review of the literature because you want to see maybe someone has already done what you're thinking of and they publish it. So you shouldn't be working on this. It's done. But maybe they haven't. But you still need to see like what is the state of the art. What are people working on? What have you done? And is your thing better? So even if you have some idea, you still have to compare it to like what people have published in the last couple of years. And it's going to be really the last couple of years for my field because it moves so quickly. For other fields, you can probably find like a method from 10 years ago that you compare it to. But for us, it's like right now, the thing that I was working on right now that I'm focused on, like all the papers are starting from, I think, 2017 up to like 2020. Those are the papers that I'm working on. It's very recent papers
Last
that I'm
3
trying
years.
Yeah, it's very recent papers. Yeah, so it's you try to like read all those papers. Like I guess like at first I was just trying. I think maybe like for a couple of weeks I was just reading a lot of these papers, trying to see like what they're doing. How they're evaluating their their methods. Is for example, I was trying to work on when you have a data set, but then labels are noisy. So what my focus is right now is I'm using that method with like the discrete thing to use it when you have a data set with a lot of images, but maybe like a large fraction of them are just wrong. Like it's usually
mislabeled when you say
just mislabeled. It's just it's a cat, but they marked it as a dog because these data sets the way they're made is you just had humans hand annotate them. You had people that you paid like some people in a poor country that were paid like
virtual
cents.
assistants or something.
Yeah, like literally they were paying like cents to just like Amazon has this like mechanical Turk. It's
I've heard of that.
Yeah,
I didn't never know what it was though, but I've seen it so much.
Yeah, people use it for research, for like filling out questionnaires, like in other fields like psychology. Like you would say, like on a random sample of 500 people, we found that they fall prey to this bias. It's basically they gave the question to like a bunch of Turkers on this platform, and they answered. For us in my field, we use it to label these images because then we can give it to the network to learn because it's they have thousands of images. You can't just do that on your own. Like you can't have like you don't want to waste the time. Like you want to waste the PhD students' time to do this. You just want to find someone who can cheaply do it, and it's basically people who I guess have nothing better to do, or like that money goes a long way in their country if it's a poor country.
Yeah.
So they label these images and shit. What was our work? What was the question?
No, we were just talking about year 4 and what you're doing right now.
So I guess right now. Oh yeah. So the reason I mentioned that is I was looking at how to apply this like new method, and at first I was looking at like papers in like theoretically how you can achieve the 0-1 loss or whatever. But then I stumbled upon this whole like subfield where this subfield is they have these image data sets and they train these networks and they purposefully like mislabel these data sets to see if the network can still learn. And so so that's how I kind of found like the niche where I was like, oh, I guess I can apply it here because it's very easy. I can take these data sets that exist like the like digits, like labeled digits or objects in an image, something like that. So it's not just cats and dogs. Like for example, there's like a data set Sci-Fi 10 that has like, I don't know, planes, automobiles, deer or something. Probably not deer specifically. That's probably in my mind.
Just because you saw one.
Yeah. Yeah. So I guess it was like reading these papers and then I stumbled upon that one and then I was reading those for like a week and I was like, okay. Then I was like, okay, I see a clear path. I have these, this data set and these data sets and I have this method. I just have to basically compare it to these other. So I implemented like the other state-of-the-art methods quickly to see like what results I'm getting with those and what results I'm getting with mine. And then I'm just like running some experiments right now on the supercomputer.
I see. Very helpful. Very helpful. Yeah. Now let's talk about after the PhD. I know you can either do like industry stuff. You can either go into industry. You can go into research. Can you talk a little bit about those routes? Which one do you plan on pursuing at the moment? It probably could change.
Yeah, I'm still actually not sure. I really have I guess I have like this year to decide because when you're starting your 5th year, you kind of have to already at the beginning of the fifth year you have to decide and just you start to apply. You could, I guess, apply to both, so you don't have to even decide. Maybe you can see like what is the better option. But I haven't really decided yet. Yeah, I would say that there's the two big ones are you either go into industry or you go into academia. And if you go academia, it's basically the professor route. It's you try to get tenure at some institution. So you work really hard for like 6-7 years. So if they hire you for like a set amount of time, and then if you're good enough at the end of those 6-7 years, they say, okay, you got tenure, you're basically done. Now you can do like whatever you want. We won't like see if you're being productive or if you're publishing papers. You just have to like teach some classes.
And you're there for life, right?
Yeah,
like you can't even get fired.
Yeah. And people change jobs, but usually they change from like if they already have tenure and you're a good professor, they could be like lured to another university, but they'll still be like hired there with tenure. Like people would not like leave their tenure to go to like a non-tenure place because why would they have like. Yeah, but sometimes I can see like people like switching,
So how competitive are the tenure tracks? I've heard notorious things about how hard it is.
It's ridiculously competitive. Yeah, it's so you can't just look at the numbers, the raw numbers, because there's like I think 10 times as many PhDs as there are tenure track positions, something like that. Like the number of PhD students just grows, but the number of tenure track positions doesn't really grow. Yeah, and that leads to a lot of PhDs just not going into that space, and so it's very competitive. But on the other hand, it really depends on it's really specific on where you are, what work you're doing, how good you are. If you're really good, then you might not have any problems. If you're at a really good institution and you're doing great research, then good for you. Your chances are really, really high, because the people who graduate in my department, they'll get tenure track jobs. Like they're all doing great, but it's only because they're in a really good department. They're doing great research, and so it's very specific on I guess like how well, like how good the research you did was during your PhD. So if you're like starting at some, let's say like this like your university that's ranked like 100, it's not that there's inherently something wrong with that university. It's that the professors there are not going to be as good. So probably your PhD is not going to be as good. So probably you're not going to just be like a really good candidate when you go on the market. So for those people, even though there's like a 10-to-1 shot like a priori. If you look at, like a really good department, like top 10 departments, your shots are probably like, maybe like 1 in 2. And the shots, if you're like at a really low ranked university for like these, good tenure track jobs, it might be like, I don't know, 1 in 100. So it's kind of like at the start, you have like some odds that you have to, I guess, try to improve. But
I've also heard a lot of nasty things about politics in like PhD programs and in academia. Do you have any experience with that? Like, how much is it merit-based versus how much can it be like a lot of political-based? I don't mean obviously not your political views, but just like playground politics in academia.
I would say not at all, honestly. Okay. I don't have any experience, but I wouldn't say that it's... So in what way do you think it could be based on like how you play the politics game? Because here's the thing, no university hires from within. Actually, MIT does, but they're weird. They think they're like better than everyone else, so they hire their own students. But no other university hires their own students. So I think it would
Is that because they want like different people? Why would that be? I don't. That's not obvious to me.
Because you would be like unbiased, I guess. You can't be like if it's a student at your university, you would be biased towards accepting them and making them like become a professor, even if they're not that good, because they have really good relationship. So to guard against like
it's like a form of nepotism.
Yeah, exactly.
Okay.
Exactly. So to just say like no, we're not nepotistic. We just won't hire from. You just don't like apply to your own university. It's just the thought of it is actually strange. So yeah, you always hire from outside, and I guess it would be hard. It's hard to see like how it would be gamed, because sometimes you don't even like know this person. A lot of times you might have met this person at conferences, so you have an awareness of them, like who they are. You might have talked to them, but sometimes you just don't even know the person before you interview them. So I would say there's probably really hard to at least at the hiring stage to have like politics play a role. But probably within a department, I would say that like sure, there's a lot of things going on. There's probably professors who like feud with each other, or there's a lot of stuff that like you can't like cross this professor. Like maybe this other professor has like a lot of power because they're the dean or something. So you can't like say anything bad about them. I guess something like that. But I mean, I guess you wouldn't in general say anything bad about a person. Like, you have to be careful. Obviously, you don't want to like
no matter what
talk.
situation you are, like,
Yeah,
you're probably not.
Yeah, but I guess like you hear things like you say like, oh, this professor, I heard that he worked with a student, but then the student, like, it didn't work out, but then the professor published like a paper without the student's name, even though like the student worked on it, but it's because like he gave up or something. It's like you usually want to like include a student, so it would be like a bad thing, but it's like hearsay. You don't really know the details. Like, it's kind of hard to, you wouldn't like hear both sides of the story. Usually you might hear like the student side of the story, because like you're friends with the students in your department. Like, I'm friends with like most of the students in the department, but I'm not like friends with the professor, so I don't hear their side. But yeah, there's probably politics going on. I'm sure. I'm sure there is.
Okay.
Yeah.
What about industry side? So who are I think big tech companies, as soon as I think of what CS PhD students have and where they'd want to be. Am I missing anybody? Like the Googles, the Facebooks, who else?
Yeah, that's basically it. So I guess, I mean, you could go into industry and like not work on research. But I think people who go into industry, they still want to like do some research, something interesting. And there's a lot of these R&D labs. Facebook has FAIR, Facebook AI Research. There is a Google Brain. There's Google Research. They have different like departments, but they're all basically doing research. Oh, DeepMind, that's another one. That's also Google, but they're all like separate, kind of. I'm not sure how it works, but they're all like different.
Funded, but like maybe different entities or something.
Yeah, or like maybe they get to like maybe when they were bought out as a startup, they got to keep like their own independence, something like that. I'm not sure what the details
like
were.
OpenAI too.
That's on OpenAI. Yeah, so there's OpenAI. There's Google, Facebook. I mean, there's also like R&D departments in the. I don't think they're like named or anything, but I'm sure like Twitter has its own R&D department, and I don't know, Pinterest, like all these big companies.
And what are those job prospects like? How competitive? I imagine those are just as competitive.
Probably nowadays they're probably as competitive. Probably not more though, because you don't have like the tenure part of it to like entice people. But they're probably very competitive too, I would say, because there's still a lot of people. I mean, they're not like huge departments. There's only a few companies, and there's still like a lot of PhD students who there's a lot of students who are like good, really good, and they want to do something cool. But I guess, I mean, like as a last resort, I'm guessing that like all of these students who are maybe don't want to do research or want to but are not able to get a job, you can always like get a job working in industry as in a non-research role, like just like at a startup or at like a financial, like I don't know, some hedge fund company. You can like just trade stocks. You can there's like many options that are open. I mean, I'm kind of lucky that like machine learning is really widely used right now. If I were a PhD student in geography or something, I guess I would have no choice but to
cartography or something.
Yeah,
probably doesn't even exist.
Yeah.
No, that is. I think that's exactly what they're hoping to hear. Is that like you do have a lot of opportunities.
Yeah, it depends on the field though, definitely. If you want to go into CS, sure, there's a lot of options. And honestly, I mean, that should be a bigger part of what people when people decide what to do with their lives. I think it should be they should really think hard about like, okay, but what can I do with what I'm doing?
Let's transfer over to some of the cooler stuff. So I'd love to hear from you. What, other than your field, what else should we be paying attention to? Excuse me. What else should we be paying attention to? And if there are people listening, what might be worth taking a look at when it comes to, if they want to do a CS PhD, what other fields are coming up? Like I know there's crypto and blockchain and all other kinds of shit.
So you think, so you're asking like within CS, what other fields?
Yeah, like what else are you looking at? Obviously the field you're in is capturing your interest, but what else are you keeping an eye on, and what else do you think it shows a lot of promise in the future?
So at a PhD level, it's actually, I'm trying to think about what other people are working on. I mean, machine learning is really big right now, so there's a lot of people working on that. And even stuff that wasn't that connected in the past. For example, it used to be very, you had people who worked on like sound processing and like speech recognition. That used to be like a kind of a different part of CS. Then there was vision, like computer vision. There was a different part. There was like NLP, like language processing, just like making sure that the AI understands like the text. And those used to be very different fields that had like different methods, but now they're kind of all together because these neural networks that I work with, they just work very well for all these things. And so it's kind of it's all blurring together and becoming like this big machine learning field. So it's a lot of like all these applied things are kind of merging together. I'm sure there's other parts of CS, but honestly, I'm not even aware of like there's I guess there's something like creating programming languages. I know that's a field. It's probably a smaller field though. There's stuff like yeah, I'm not sure how I guess up and coming that is. Honestly, other than machine learning, it sounds bad because it sounds like as if I don't know like what else you can do with CS. But what else is there? Honestly, I'm not even sure. I guess there's like yeah, there's cryptography, but I wouldn't say it's like a big field coming up. I know there's definitely stuff with the blockchain um, going on right now, but that's more applied, and I think I see that across fields. There's even people in my business department that work in blockchain, so it's definitely like a bigger. It might be a big thing. I'm not sure. I'm actually kind of skeptical of that in general in blockchain, but that's like a completely different topic.
Yeah, I feel like you have some thoughts there, but that's beyond the scope of this conversation.
Honestly, I'm having a hard time thinking of like other fields.
Well, I do think that that's revealing in a way. Like it's neat to see that just because you're a CS PhD, I don't mean this isn't not like talking you down, but like just because you're a CS PhD student doesn't mean you have like entire breadth of the field. You know, it's still like because I think that might be intimidating to a lot of people. Like, and when I think of people who have their PhDs, I automatically think that they have this huge berth, you know, and it makes me feel like it's something that I could never do, or it's like, wow, you know, it makes it seem like they're in another tier, right?
Yeah,
you know, but I think it's good to be realistic, and I think that your answer was very realistic, you know. It's like
I mean there's fields I just don't know like how hot they are right now, you know. For example, there's like computer architecture, you know, people use it. I guess you get hired like Intel or AMD, so like that would be like really low level stuff where you're just coding like the registers or like the really low
hardware level.
Those are, I mean, it might be a big field. I'm not sure. I feel like there's probably not. It's probably very practical, is what like my prior would say on it, but I'm not sure. It might actually. I mean, who knows? There might be like departments who work on it.
Okay. And you know, I'm curious. I've always heard that something what makes a good researcher and what makes a good like scientist is having interdisciplinary interests. Does that play at all into your life? Like, do you ever have your other interests that bleed into your research or into your work when your drive for CS that might, you know, make some unique synthesis?
Yeah,
or is that complete bullshit?
I'm definitely. I mean, in general, I love science. I love reading about science. I read like so many books completely unrelated to my PhD. And I've always tried to think like, oh, can I like connect this in some way? I haven't found a way yet to like connect it to see if I connect in a way. But I mean, I guess it's good to have that, but I don't think it's necessary. I know a lot of people, even in my department and other PhD students that are not that interested in like science in general. They're just interested in what they're working on, and it's like, you know, that's what they do, that's their job, and they read on that and that's it. But they don't like think about like the universe, or you know, like what's like, I don't know, is AI gonna kill us or something like that. They probably just are too like not too focused. That sounds like I'm judging them, but like they're just focused on their on the research. But I guess, I mean, I don't know, maybe you become a better researcher by not wasting time like I do on reading books.
No, I'm sure it'll help you down the line. You know, I'm sure there are different types of researchers and scientists. Like, I'm sure there's ones that are more focused and ones that are willing to explore other fields, other tangentially related topics, you know?
Yeah, there's always the birth of new fields. I mean, I guess you never know. You never know who's gonna, I guess, create a new field by merging like two different fields or something.
So deepfakes, we hinted at it earlier, but what are your thoughts on those? I'm on like the apocalyptic side, where I feel like there is an opportunity, and there will be a time where we at least cause sufficient pandemonium with a well-timed, well-placed deepfake that does some damage. What are your thoughts on those?
So that specific scenario, I would say it is possible, but why I'm not that scared is so two reasons. First, on the academic side, I'm seeing papers come out where they are able to detect the difference between a deepfake and a non-deepfake. Turns out you can kind of look at like basically like kind of the distribution of the pixels, or like there's the edges or something in the picture. You can basically you can. So what I was working on with like with the GANs before, they basically have these these networks that they can just be fed images of deepfakes and real images, and they are able to detect with like better than chance accuracy what is a deepfake and what's not. So there's something there, right? Now maybe it's just here for now. Maybe in the future is going to change, but I think it seems like for now all the methods have like their own signature that can be detected in the image, so they can tell like, oh, it's. I mean, we know like what architecture, like which network you're training. There's like a few methods for deepfakes, and so you can even like detect which deepfake is doing that. So that's one thing. Although that might not hold for long.
Well, but I mean, honestly, I'm ashamed I didn't think about that. But like it sounds like as we develop methods for deception, we're also improving on our methods for detection.
Yeah, exactly.
And I feel like it's synonymous to saying like, yeah, whenever the computers came around, like computer viruses were probably like scared the shit out of people. But then obviously you create there's cybersecurity comes
along.
And
like antivirus.
Yeah, software. Antivirus software. Yeah. So like, while there might be bad actors with great technology, but there's also people that can easily detect it, and those methods hopefully will keep up.
That's true. I mean, I remember viruses used to be a big problem. Like I remember, when I was a kid, I played World of Warcraft, and my account got hacked. I had like a couple of Trojans, and I feel like now I don't even remember when's the last time like a virus was even detected on my computer.
It's such a background issue now. Yeah.
Yeah. So that was one reason. Now the other reason I'm thinking is I think we're just gonna like these already exist, and I think if we're talking about someone falling prey to that, you could. I mean, it's easy enough for someone to just share it on Facebook right now, share some like bad deepfake, some video of like, I don't know, Trump saying that he's declaring war, or I don't know, something to panic the people. I mean, you can already do that, and I don't see it like becoming viral. I mean, I don't see it in like, I literally mean I haven't like seen something become viral where people are like, oh my god, what is this? What's going on? And I think that's probably because people understand like maybe I can't just trust this if I just see it on Facebook. So what I'm thinking is
optimistic.
What I'm thinking is going to happen is that people are going to go look at a news source and see if a news source is saying that this is real. Because if a news source is saying that this is not real, or not saying anything, or it's saying it's fake, then you know it's fake. So, for example, if I see that Trump declared war on Russia tomorrow, well, he wouldn't on Russia because he loves Russia, right? But on China, let's say he declared war on China. I can just check the New York Times. And the New York Times doesn't have like a breaking news segment on this war declaration. Then I know it's fake. So I guess maybe for people that wouldn't think to like just quickly Google it and see if it's real, then I guess I don't know. I guess that's my thought process. I mean, the other day I saw a picture of Joe Rogan moderating a debate between Biden and Trump, and it was really well photoshopped. and I was being trolled, and the person was like, "No, dude, it's real." I was like, I don't think. I Googled it and I couldn't find any data on this. So I was like, I think it's fake. And then I even went to the Joe Rogan subreddit and I found in like the top of all week someone like posted the really good Photoshop. So I was like, okay, this is fake. And he was like, okay, I'm trolling you. But I guess I did spend like 5 minutes doing that. But I guess maybe that's too much to ask of people.
Basically, it's just not that hard to verify. Like it doesn't take a lot of poking around to show that certain channels aren't picking this up and don't seem to make anything of it. We're less reputable. People with way lower credibility are just spreading it around like that might mean something.
I think that's gonna save us. Yeah, that's what I'm thinking. But maybe not. I mean, it only
takes
one example.
It's kind of like a herd immunity in ways, like same deal.
But only take one example of what you said. For something to go viral and people fall for it to be true. So you never know until it happens.
Yeah, sometimes I think about it's not even like specifically big ones like declaring war, but imagine if, because there's a lot of like talk about China covering up coronavirus body counts, right? And like the CCP is notoriously just secretive, and so that already creates an air of like, are they telling us the truth? And imagine if there was a deepfake of like that just showed a truck driving in, and it had like something that looks like bodies in the back, and it was like a 5-second clip, because like, a lot of the clips that come out of China are like these weird pixely images that are already low fidelity.
They're like zoomed in from like very far.
And I imagine something really dumb like that. Not even like a really elaborate fake of like President Trump giving a speech, declaring war, but just something like that, and then all of a sudden it just fucking goes around like rapid fire. People dying like dogs in China, like I don't know. But I'm glad to know that you're an optimist.
Yeah, I guess I'm thinking about, because that already exists with images, right? Photoshop has existed for like 20 years.
That's very true.
Have we I guess I don't know. Maybe we've fallen for something really bad. I'm trying to think if there's an
I don't
example.
know. I can't think of anything off the top of my head, and I feel like if there were sufficiently bad, you would be able to.
Yeah.
You'd be able to point to it and be like, see, this is what's coming with video, you know?
Yeah, and people lose their jobs over like photoshopping. I know there was an image where someone photoshopped like the BP oil spill and Obama being like very sad about it, but it was actually two different pictures. He was sad about something else, I think. So just like photoshopped him, looking kind of distraught in front of the oil spill, and I think the person lost his job. It was like a Time magazine or something. So I guess they don't they really take it seriously. They don't allow these like photoshops. So I'm hoping it's gonna be the same with the videos.
I think so too. It's been a great conversation, man. I appreciate having you on. I do want to turn it over to you. This is like your chance to say anything you'd like to anybody who may be listening about a PhD. It could be anything really. Is there anything that you would tell yourself, I guess, about to start a PhD, knowing what you know now?
Don't do it. We're still No, I would say, one thing that I forgot to mention that is actually really important. This is before you would want to do, before you start a PhD. You just have to, you need to try to do research before you try, even if that research doesn't go anywhere, just try to do research, try to work with a professor, try to see if this is something you'll enjoy. And the best way to do it is to literally just try it, spend, a couple months, a summer or something, see if it works out, see if you're interested in it, see if it's fun for you, because that is like the biggest, most important thing. If it's not fun for you, it'll be like hell. Like you wouldn't be able to go through with it. I think that would be the, I guess that would be my takeaway. Just make sure you try to do some research before you apply or start a PhD, hopefully before you apply so you don't waste your time. And after that, I guess, find a good advisor as we talked about before. Yeah.
That's a wrap, y'all. Thanks, Alek. Appreciate it, man.
Thanks for having me, Sailor.